Good morning, and thank you for joining us at GIS. We could not be more thrilled to be joined by this incredible panel this morning. This lively Ask the Panel Anything is hosted by Esri partner EOS, a 2020 GIS award winner. Joining the panel are two Esri product leaders, Jeff Shaner and Ismail Chavite, alongside data collection power user, Zach Pettix of Palmetto Engineering, who just returned from months collecting data in harsh environments in the Sonoran Desert. Moderating today's panel is Eric Geckstetter. To you, Eric.
Hey, thanks a bunch, Jessica, and great to be here for this high accuracy mobile interactive panel. Boy, it's a great panel and with a lot of experience here. You'd probably call it even world class, or at least I do. But first of all, I'd like to thank EOS for sponsoring this and sort of putting this all together and bringing us all together. So there's me. I've been in the GNSS industry for about 30 years now, and joined by Jeff Shaner, Ismail Chavite, Zach Pettix, and Johnny Latour from EOS. And so let me do this. Let me go ahead and pass off for a couple minutes intro of each guys. So Jeff, why don't you start us off?
Sure, thanks, Eric, and thank you to EOS for this panel discussion. My name is Jeff Shaner. I'm the Field Apps Product Engineering Lead at Esri. I've been with Esri for 25 years now. Surprisingly, I'm only 35 years old. I don't know how that happened. I must have started when I was young. And I work closely with our product development team, kind of filling the backlog of new development work we do. So that's me. Thanks.
Ismail?
Hey, thank you, Eric and Janiv, for the opportunity to be with you today. My name is Ismail Chavite. I work in Esri as a product manager, and specifically I'm focusing these days on Survey 123 and ArcGIS Quick Capture.
Great. Zach?
Good morning, everyone. My name is Zach Pettix, and I'm with Palmetto Engineering. And I've been using what I like to call the vanilla Esri solutions now for, I'd like to say, since they were launched. And we've had a lot of success. We've enjoyed using the apps. We've enjoyed watching the technology grow, and we're looking forward to pushing into the future.
Well, I can relate to you, Zach. Man, I've been a power user for a lot of years and spent a lot of field time. And so, yeah, it's been fun to watch the evolution for sure. Johnny?
Good morning, everyone. Thank you for being here. And I first want to thank everybody on the panel for being present and for the Ask Me Anything session. My name is Jean-Yves. I'm based in Montreal with EOS Positioning System. I'm the CTO of the company. I've been involved since the very, very early days of Bluetooth, designing Bluetooth receivers back in the early 2000s. And at EOS, I handle a lot of the product development and app development also. And we will be waiting for your questions.
Great. And so just by way of background, I'm Eric Geckstetter. I've been in the GNSS industry, like I said, for about 30 years now as a product manager developing hardware and software, and then wrote for GPS World Magazine for about 10 years as a high accuracy person. I've spent a lot of time in the field, mapped a lot of golf courses, believe it or not. So anyway, so sort of the format here that I like to follow is we'll do an Esri mobile apps overview that talk about the ecosystem, just a really short, just a summary of it, and then really focus on questions from the audience. We really want to follow a sort of Ask Me Anything Reddit style, because it's all about the audience and making sure their questions are answered. And then we'll fill in between those. We'll fill in. We have some case studies here. We may or may not get to all of them, but they're great discussion points if we need to spur conversation. So this is the ecosystem, and I really, from my perspective, it's been fantastic to watch this ecosystem develop. As I developed software back in the 90s for field data collection and PC post-processing or data processing and mapping. And Esri has an entire suite. And so I just, from a user perspective, I want to talk just for, 20, 30 seconds about what it means to us as users and for our clients. And then maybe have comments from Jeff and from Ishmael about their specific products. So there's the ecosystem from a field perspective involves field maps and collectors. So collector is the current deployment, and then field maps is an extended deployment, or the next generation deployment. Then there's Survey 123, which is smart field forms, quick capture, a really fast application for recording really fast data, tracker like a breadcrumb trail, navigator for guiding, workforce for management, and explorer for awareness. And you have all these apps here, and I've got a next slide here that Jeff can comment probably on is how he's bringing a lot of these apps together in field maps under one umbrella. But really, the center point of this slide you see is ArcGIS Online, or it could be Portal if you're on premise. But how these apps all work together to feed into that central ecosystem. It's really a powerful tool, and it made it, I think that the shift that Jack made from going from client-based local computer to cloud has really been, I think, impressive to me. And it builds this amazing platform that all these apps feed into. You could have Survey 123 open and Collector open at the same time with an EOS receiver and be populating the same database. So it's pretty cool. So I don't know, Jeff, if you want to talk just a minute about anything that I missed in there, or just to summarize.
Yeah, that's well spoken, Eric. I think, a few of us have been around in this business on the mobile side for a long time. And that big shift came, I think, when Apple really introduced the iPhone, right? And we saw Google with Android devices kind of rocket off into new development. The two platforms before that, we were really just focused on an all-in-one handheld option running Windows Mobile, right? And that's what most organizations used. And we had a couple of products back then, like ArcGIS for Windows Mobile and ArcPad, which were well used for field data collection. When the smartphone and tablet industry took off in the 2000s, we engaged quite heavily in building a suite of applications that were focused on each individual activity that people engage in, like you see in the slide, planning and navigation, and using maps to understand what's happening in the field and keep them up to date. And that ecosystem is evolving, and that's what we're building with field maps. But we've kind of stepped back and taken a look at the industry trends, and we've been thinking about how to best deploy solutions and workflows in the field, and taking the capabilities of each of these individual apps that we've been focused on and bringing them together in a unified experience. And we're just waiting on some Apple approval right now, and the first launch of ArcGIS Field Maps will happen. So we were hoping it might be Thursday this week, but it looks like it's probably going to be Monday, just about where we are with the App Store approvals. But
as you were talking, I popped up the field map slide just to show.
Oh yeah.
It's gonna combine a Collector, Workforce, Navigator, Tracker, and Explorer under one umbrella, under one app. That's sort of your next gen move.
Yeah, and this update that we're doing here this week or early next week will bring 3 of those 5 apps together. Really, the mapping capabilities that are part of Explorer, the data collection capabilities that are part of Collector, and that breadcrumbing you mentioned, the location tracking capabilities of ArcGIS Trackers. Those 3 combined are part of this first release that's happening.
That's great. Hey, Ishmael, can you give us an update on Survey 123 and Quick Capture? Anything new coming out, or talk about the new stuff that's coming out?
Yeah, absolutely. We have an ambitious plan for the next few years for Survey 123 and Quick Capture. Quick Capture is basically an application for rapid and at-speed data collection. So it's very lightweight and focused on that task And some of the things that are coming up very soon include integration with oriented imagery. So you can snap photos from the field and then have a great experience with oriented imagery tools from ArcGIS Pro or even from a web browser. We also just released integration of quick capture and survey in some workflows. You want to quickly, drop a few points as you are moving or capture very quick field observations, but sometimes you want to go a little bit deeper with forms. So now quick capture integrates very nicely with Survey 123. This we just released a couple of weeks ago. On the Survey 123 form, the two fundamental areas where we are working for next year are integration with machine learning. So you can automate field data collection tasks from Survey 123 smart forms. And we are also developing an extensibility framework. So you can integrate more easily smart forms with your own sensors, but also you can control the workflow of the user as they complete the smart forms and manage their own assignments for the day, etc.
I tell you, you guys are doing a great job of extending the capabilities of these applications. Just, it's fun from my perspective watching this happen, because we were so limited, even 5-6 years ago, we were so limited in the field tools we could take out on iOS and Android devices, and it's just it's very powerful today. Zach, what would you say about that? I mean, you've been around quite a while too, from a field perspective and an office perspective too. How have you seen the evolution of these mobile apps sort of happen?
Well, it's been interesting. My background was working and developing actually field stakers for telecom and electric for the last 10 years. And I'll be honest with you, people told me that Esri would never be able to offer the type of field solutions that some of the specialized third parties can do. And, I think a lot of people are pleasantly surprised. And it really does come down to, I don't think if you're a utility that has a staking solution, or, you have a very dedicated solution, maybe you should look at Collector and Survey 123 as a way to augment and maybe be more proactive in the field. You don't really want to remove one solution, but maybe use Collector or Survey 123 to enhance the data collection. But I will say this, it's been a game changer, and a lot of utilities right now are legitimately looking at these solutions as a way to add another tool in the toolbox of gathering good data. And Eric, the other thing too is that with the EOS GPS and high accuracy receivers, what I'm seeing right now is, the reason we map things is so we can manage things. But when you map things in high accuracy, you are managing them in high accuracy. So just the level of data and the quality of data has gone up. And the tools are easy. The days of studying at the altar of GIS to join the priesthood to deploy these apps are over. You can be successful in the field now.
Right. Hey, so I'm going to go to the first Ask Me Anything question, and I'm going to focus on Jean-Yves. And I think I was actually sharing my Ask Me Anything questions screen there for a minute. But there was a question about vertical accuracy, and Jean-Yves, I wonder if you can address that among these different Esri mobile apps. Did we lose Jean-Yves?
Sorry, had to unmute myself. Can you tell me the question on mobile accuracy, please?
Sure. So there was a question about vertical accuracy in the Esri mobile apps. How is that available in all the applications, or how does that work?
Yes, you can get you can get elevation in every single one of the Esri apps. The receiver provides you with an elevation, and this elevation the accuracy depends on the type of receiver you're using and the source of differential correction. So if you are using a sub-meter receiver, you'll get about, I would say, anywhere from 0 to 2 or 3 times the accuracy of your horizontal. That's a rule of thumb. And so if you're doing sub-meter, expect anything from 0 to about 1.5 meter, 2 meter elevation error if you want. If you're doing centimeter, you're having 1 to 3 centimeter horizontal, expect anywhere from 0 to about 5 centimeter on your vertical, and this elevation can be stored in the Esri app. There is also one thing that we have added for our users. A lot of people were asking about to implement support for various geoid models around the world to get a more accurate elevation that fits the nation vertical data. I mean, in the case of the US, for example, it's called the NAVD88. And this is, we use a geoid model to convert from GPS elevation, which is ellipsoidal, into the autometric heights of the NAVD88. So we support quite a few around the world. We keep on adding them on demand, depending on countries. But for example, the latest one for the US, the GeoID 18, is already supported.
Yeah, so that's a good point. So I think to be clear, you can provide, or the EOS receivers can provide survey grade accuracies, elevation accuracy within all the Esri mobile apps. Is that correct? Are you still there?
Yep, sorry, you always have to unmute yourself. This is a story of those past year, muting and unmuting. Sorry. So yes, and you can provide this elevation. So the receiver really outputs, we take care of everything, handling everything, and then you push everything into the apps. And now with the addition, since a year and a half ago, correct me if I'm wrong, Jeff, the Z value also is stored in Collector.
That's
And,
correct. Yeah.
Yes, exactly. And then you get the elevations also on the other apps. In the Quick Capture Survey 1, 2, 3, you get elevations directly in these apps.
And that's across all operating systems or just some?
Across all operating systems, whether it's iOS, Android, or Windows, we take care of that. And also, that the problem that our users were having is that they needed to do a post-processing afterwards in the office. So when they got the elevation of the receiver, which was usually mean sea level, not very accurate, or they got the ellipsoid, they had to transfer it back to ellipsoid. From ellipsoid, they had to go into ArcGIS and then do all these transformation to apply the autometric height and then get the results after. With this solution, you have it directly in the field. There's no processing needed. So the idea is always to match Esri's philosophy of a real-time solution, where you're in the field, you just press a button. I mean, once you submit, your work is done. You got no other thing to do back at the office, and people from the office can see everything that you do live in the field. So embracing that real-time workflow, if you want, is what we do with the autometric height.
And I think as a field user, being able to consume that metadata into ArcGIS Online or Portal really means a lot, because if you need an audit trail to go back and say, okay, hey, you know, what was going on with this point? We have all this GNSS metadata in addition to the elevation, the survey grade elevation, that really makes it a traceable solution. So there was another question about field maps and utility network. I wonder if you can comment on that, Jeff.
Yeah, that's a great question, and I think it's an important one given the infrastructure conference. So today, I think one thing that's really important to understand about field maps and even Collector from that perspective is that it works with your transaction model. So in order to collect information and especially update information that's stored inside of your enterprise GIS, you want to be able to leverage the transaction model that's applied to your feature layers. And with the utility network, that's employing branch versioning. If you're not familiar, there's traditional versioning and branch versioning that are part of that enterprise approach. Because field maps and Collector use the sync framework, feature services in the sync framework handle the management of versions for you. So right now, if you wanted to work offline, disconnected in the field, and edit features that participate in your utility network, you can do that, and the edits will go into that branched version. But we do treat it as simple features. We don't execute any logic of the utility network in the field. We have some development work that's planned. We're going to start prototyping it in the last quarter of this year and hope to release it early next year, where we're going to extend the capabilities of our field apps and field maps specifically around the utility network. The most important things we're going to do first is the viewing of associations and containment in the map. So you can see that connectivity in the network, be able to support the inspection against those associations, be able to support in the map the subtype group layer and the utility network layer. And by doing that, then we'll start to bring in additional capabilities. We're looking at adding support for tracing against the utility network as well, so that you can do all those troubleshooting workflows and those design workflows while you're in the field. So we've got a lot of work coming on the utility in this with support of the utility network. I'd say that one other thing that's really important around that, it's even more important than just the utility network, and it's coming into hosted feature services and it's coming into the runtime. And when it's there, we'll be supporting it with our forms work and field maps, is the attribute rules capability that's associated with the development of the utility network, as well as contingent values. So if you've been asking about or looking for those capabilities, they're coming, and they're coming in like early next year timeframe by the time it gets plumbed into the rest of the system.
Good stuff.
Yeah.
So I'm going to move on to the next slide. The field map. We already went over this a little bit, but just maybe give a 30-second highlighting on that, Jeff, please.
On field maps, well, we kind of talked a little bit about it already. You know, we are bringing together these individual apps. I mentioned, you know, for this fall release, it's really focused on Collector, Explorer, and Tracker. But we're also doing more than just merging those apps together. With this release that'll happen this week, a couple of key additional pieces that have been worked on is support for indoor mapping. I know we're all focused upon outdoor here, but I'll just mention that we've added support for the indoor information model with field maps. So if you do have a facilities layer inside of your map, and your map has been, the layers in it have been authored to support the indoors model, a floor picker will appear when those facilities are in view and let you filter based on floors, and will show floor information. And that's just a starting point of deeper integration with indoors. The second phase of that will be bringing in the indoor position as well. And that's going to unlock a whole bunch of new kind of streamlined editing workflows for indoor mapping as well. So we've done that, and we've started on the integration points. It's a platform integration of smart forms. So bringing in the ability to extend beyond what the pop-up definition does for editing on a layer, and introduce a new forms concept. And that form information is stored as a part of the web map. Field maps is just kind of this tip of the spear for that, I guess, because it is driving the field aspects of the form data collection effort. So we're doing some basic things to start with, like organizing your attributes into groups and supporting conditional visibility. But next year we'll be doing calculations and much more, and growing that capability. Interestingly, by putting that form content into the web map spec as an ArcGIS Smart Forms capability, the web editing in the new ArcGIS viewer that's in beta today, it also supports it too. And so you're going to start to see forms everywhere in the platform, not just in one app. It's going to be all over the place, and that's a huge advancement in the whole platform, I think. And a lot of the smarts underneath it are going to take advantage of that arcade expression language.
Mhm.
So if you haven't invested in learning as a GIS professional about arcade, I think now is the time to really invest in it, because not only is it affecting these forms moving forward, but it's also how you can alter symbology, how you can do labeling. There's just a lot of advancements with arcade that I think you can make in how you manage and work with maps.
I know our folks around the office here talk a lot about arcade and how they use it. So yeah, I'm with you there. Hey, Ishmael, there's a question from the audience, Ishmael. When collecting high accuracy point data through Survey 123 with an EOS receiver, do I need to add the GNSS metadata fields to the connect form? Are those fields stored in the GeoPoint question? Does that make sense? Oh, did we lose Ishmael?
Hey, sorry, I was on mute.
Okay.
Yes, in regards with the elevation from day one went into the geometry field in Survey 123. So that has always been there. Then in regards with the metadata, you don't have to add the Esri GNSS fields necessarily. You can choose on what fields you want to store, which metadata. So in Survey 123, we work with this notion of calculations. So you can build logic in your smart form. So as the NIMIA sentences come from the GNSS, we can extract values and manipulate them and put them in whatever attribute you have in your own feature layer. So you are not constrained to a particular schema. You can use the Esri schema, but you can also use your own schema to store this metadata and even to create data validation rules in the application itself. So it's not just about storing the GNSS metadata, it's about using it real time while you are capturing the data. You can use those values to create your own constraints for data capture.
Just to be clear, we answered that. The second part of that question was, are those fields stored in the GeoPoint question?
Yes.
Okay, perfect.
Yeah. GeoPoint question and attributes again, right? Like if you want to store the number of satellites or the fixed time or other attributes, those go actually in attributes. But the X, Y, Z coordinates, they all go into the GeoPoint question.
Okay. We have a ton of questions here. I'm going to try to
Eric,
meet
can I
with them here.
to the GNSS question too. We did, we ran the tools to populate those into our field collections so that our field collectors could see those fields. Because we were testing the accuracy in real time in the field. And so, as Ishmael was saying, they're natively captured through the EOS unit as well, but it was good for our people in the field to see those fields being populated. Again, when you're collecting at high precision and high accuracy, the quality of the data they collect goes up. They know they're being managed at a decimeter scale or better. And it's funny, they're more methodic with filling out the forms. They're more methodic with letting the GPS receiver cook off and being accurate. So, there's a lot of advantages to having those GNSS fields there. And we were working with multiple receivers in the field, and
Right.
we were working with different schemas. So I was having to map some of the data to different fields, and it was all, again, with very little programming, we were able to do all of that and be very successful.
And I think the serial number of the receiver is actually uploaded too, so you know specifically which crew is tied to which data, right?
That's correct. And we were able to actually use the built-in analytics in Survey 123 to gauge and plan in the field. And that was a huge, for this last project we were working on, that was a huge, huge factor in using Survey 123.
Hey, Jeff, another question for you. When accurate GNSS data will be, can you explain in the session if and when accurate GNSS raw data will be enabled for line and polygon layers in ArcGIS Collector?
Yeah, that's a great question. We've talked about taking the GNSS metadata and applying it for lines and polygons, which I think is ultimately what the question is, since it's there for points, right?
I had to think about there for a minute, right?
Yeah.
So the metadata is not there for the vertices, right?
They're not there for vertices, and there really isn't vertex level metadata inside of ArcGIS, right? We don't have that concept. We could store the raw data, which might be also the question. It's kind of ambiguous. What's the real question there?
Right.
But that would be independent of the data collection, right? It would be like taking a GPS session of information and just storing the raw GNSS data that's logged, and then somehow matching that back up. I guess it's not really an answer, but it's a question back, and something we've been asking ourselves about that and looking for more information on is, what's the intended purpose? Is it that you want to take that raw GNSS data and post-process afterward, right? I mean, that's something that has historically been done, but none of us have taken that approach with smart forms yet, right?
Yeah,
So
I don't think
if
they're talking
that,
about post-processing. I think they're talking about, and I know what they mean now after I thought about it. So for point data, you get all the GNSS metadata, but for example, you could get a PDOP or whatever, but for vertices, you don't get that individual information. I think that's what people are after.
So in that context, I guess the question is whether you want to see that averaged, right? And then what would you do in the instance where maybe it's a linear geometry or a polygon geometry and someone were to modify it with a map? We've talked about constraining in field maps so that you can only collect and update using GPS, and then we could enforce that. But in this mixed mode of being able to, pick up and move a vertex of a geometry or delete a vertex in a geometry, that can really impact what the true measurement would be. It's not really then a GNSS measurement, right? It's yeah. So there's some considerations there on the solution, and knowing what the intended end goal is, I think, is really important.
Right. If I may add, we just had an experience with a user that had a similar request. So the way this was done with Survey 123 was that basically, when you start digitizing your line or your polygon, you don't use the polygon tool or the polyline tool, but you rather start adding vertices to your geometry, and then the polygon or polyline is calculated on the fly. So what happens is that while the vertices of the polygon or the polyline don't have the GNSS metadata, there are corresponding point features that coincide with these vertices that do. Right? So that's kind of a simple approach that you can model with Survey 123 smart forms. Similarly, with quick capture, we had this scenario, or actually some guys from Canada, they wanted to, and they did, map mountain bike trails, right? And they wanted to have the GNSS metadata for every vertex along those polylines, these trail tracks. So they similarly configured quick capture to not only create a polyline as these guys were driving the bicycle, but they were also dropping points at every vertex of the line. And that vertex of the line contains all the GNSS metadata.
Gotcha. Yep, I understand your concept there.
Yeah. So in the end, you have two layers, right?
Right.
Polygon and the corresponding vertex.
Yep.
Yeah, we did a similar thing with Collector for Dutch Cadastre with the workflows around data capture there, where you could simultaneously capture point features along with the polygon geometries. Yeah, so I think that is an approach. I think then it becomes a question of how do you manage that content effectively and maintain that improved accuracy in your GIS after? Like, do you use a topology to manage that, or what do you do with it after, right? I think that'd be something to understand better too.
And Jeff, that's interesting that you mentioned that with the high precision data collection that we were using in the field, especially in our telecom work. An interesting side effect is we wrote some scripts using Arcade and Python to do stationing on the fly in our as-builts. So once the guys were in the field and collecting these high accuracy points, we were doing updates and additions from field collections. Instead of having to rerun and manually calculate all of these stationing fields, which in the telecom business is that they live and die by that, we were able to automate that process. And so if the client had a request to do a work order change, or there was some issue in the field, as Ismail was saying, we could look at the high precision points and kind of recalculate and stuff. So it's a game changer. It really is. Having that certainty of that your data in the field is correct.
And have the audit trail is a big thing I hear about, right? Having that audit trail.
Eric, I'll say that we had to have the metadata in there because most of our clients are asking us for, and they use the term loosely, survey grade data, and
right.
What that is. But I wanted to be able to go in and say, we maintain these data level precision and accuracy through the entire collection. And in areas where if we couldn't get, for whatever reason, somebody made an update using their iPhone and they were collecting an inspection, we still wanted to have that data there, but we want to be able to say, hey, this is literally a red line that we're creating on the fly. This was not a field collection, and differentiate that from, for the client.
And I think the GIS world still has a hard time wrapping their arms around the fact that you can get survey grade horizontal and vertical accuracy within all these mobile apps. It's just something that's totally new that we haven't really seen before in years past.
It's become easy. It's become very, that's the whole thing. And again, the technology is moving now very fast. And again, I'm seeing a lot of clients are asking me, do we need to have these very elaborate base stations and all this stuff? And I tell them it depends on the project and the area you're working in, but now you have more tools in your toolbox to be able to do these type of field collections.
So that leads into the next question. Actually, it's about base stations. It's to Jean-Yves. The audience is asking, I attended a session earlier where the utility installed a base station. Is this a better option than using an RTK service? And I'm going to skip through a slide here and show a picture of a base station. There's one right there to see so folks know what they look like. This is one of them at least.
Right. This is a very good question. I mean, my simple answer is if there is an RTK network available, especially if it's free, go for it. That would be the best option. A lot of states have free RTK networks. I think, for example, New York, Oregon, Florida, they all have RTK networks. Why would you install your own base station? There might be a couple of reasons for that. The first one, let's say you have multiple receivers in the field. Let's say you're operating, let's say 50 crews in the field, and the state in which you are does not provide for a free RTK network. So if you add the cost of what it would be per receiver to get an activation, you multiply that by 50, and that gives you a yearly budget. And for probably a very small fraction of that investment, you could own your own base station and broadcast. You can cover, basically, depending on the level of accuracy, it's about 1 centimeter error per 10 kilometer baseline, if you want, with your base station. So we will provide the receivers, for example, the Arrow Gold will provide with anywhere from 3 centimeter accuracy average when you're 50 kilometers, about 30 miles or so, times 1.60, whatever, do the math. About 35 miles radius, you'll still get 3 centimeter accuracy. I personally do testing from Montreal with a New York base station, and then it's about 108 kilometers, and I still get about 8 centimeter accuracy. So it depends on what you're looking for. So one reason for having your own base station is if it's not free and you have a lot of receivers in the field. And you can even install multiple base stations to cover a large area and still save a chunk of money every year. Second reason is that nowadays we talk about GNSS, which is Global Navigation Satellite System, not just GPS, the US constellation, but to that we add the GLONASS constellation, the Chinese Beidou constellation, and the European Galileo constellation. So you have all 4 constellations, and you crank up the number of usable satellites in the field from about 7, 8 GPS only to about 32, 35 GNSS satellites. So what does that do for you? Does it increase the accuracy? Not necessarily, but it allows you to have more productivity in the field. Let's say you're under a light canopy and you have access to more satellites. So you're being phenomenally being more productive than just GPS and GLONASS alone. And that's another reason. A lot of RTK networks are still supporting GPS and GLONASS only. We're seeing Florida is the first one who has integrated Beidou phase 3 satellites in their differential correction they provide. So they have all 4 constellations right now. They're still in testing for Beidou phase 3, but some of the stations you can connect to them have all 4 constellations. New York is only doing GPS, GLONASS, and Galileo. They have not embedded Beidou. And a lot of the states might remain only with GPS and GLONASS only. So decision is yours. If you're in the wide open, you have no challenging conditions, just go with a free RTK network. If you have one receiver, paid RTK subscription, go with that, and it's not worth investing in a base station. But for the other 2 reasons.
I'll echo your comments, is that it really is a productivity question. I mean, and we did quite a bit of study here in Oregon with 2 constellation versus 4 constellation. We measured the productivity increase of about 50% more productivity, 2 constellations or 4 constellations over 2 constellations in challenging environments. You're right, out in the wide open sky, it's sort of irrelevant, but if you start to get near buildings, under canopy, those kinds of areas, your own base station pays for itself really quickly with those kind of productivity increases. All right, so what I want to do now is the first case study was New Jersey American Water. I actually presented this with Chris Kahn. It's in another part of this section of the IMGIS conference, where we go into a lot of detail about this project. It's really a great project, but I wanted to give Zach enough time because we have so many questions here that we're going to try to get through. There's no way we're going to get to them. We'll handle those later. But I want to make sure Zach had a chance to talk about his project. And so Zach, why don't you take this over? I've got about 3 slides here, and then if we need to screen share yours, we can do that too. So take her away.
Sure. So we were contacted by the Tohono O'odham Utility Authority, which is a tribal utility in the southern part of Arizona. They're the largest, from what I understand, the largest tribal utility in North America. Their service area is about the size of Rhode Island, but they were moving and updating from paper maps and basically a lot of legacy data, and wanted to move into GIS. And this whole idea was to go out there and basically shoot their system and fill in the gaps of a lot of blind areas where they had no data or bad data. And this was going to prep them basically for deployment into utility network. So, we went out there and we used Survey 123, we used Quick Capture, we used Collector, and to kind of build a workflow and shoot the system. Unfortunately, COVID hit right when we were getting ready to go out, and we found ourselves getting backed into the deep of the Sonoran Desert in the middle of August to shoot a system. And so not only were we, battling with the setting up the devices and working basically, but we were working in 130-degree heat. So wow. What we found out was if it's going to fail, it's going to fail in that environment. Mm-hmm. And there's a lot of considerations, I think, for a lot of people on this who are attending this presentation. There's a lot of little gotchas that you don't think about when you're sitting at the office and filling out your forms or deploying your schema. And it really became for us an exercise in how can we squeeze as much efficiency? How can we speed up collections in an environment where 30 seconds in the sun and your device is going to fail? And when I say the device, we were using iPads and iPhones initially. And there's some limitations with what the thermal range and that those devices can work in. And we quickly, through failure, honestly, it was failure. We bought all sorts of cooling fans and everything. And what we found out was we had to back our collection to the wee hours of the morning. We would go out at 2 a.m. in the morning and start shooting the system. And we were looking for ways, like I said, to squeeze the most amount of collections in a day in the minimal amount of time. And that means having receivers and equipment that could do fast acquisition, fast forms, and make it as simple as possible. You really want to utilize all of the domains and pick lists and everything that you can in your data. But I was telling some of the folks from EOS, 30 seconds in the sun feels like an eternity when you're standing in a cactus patch.
Yeah.
Again, the guys, when it becomes uncomfortable, their level of detail and attention in the field drops, and so we were looking for fast acquisition devices. And, as John Eves was saying, high precision and maintaining that precision in the field. We were lucky enough to be able to pick up some RTK signals from Phoenix, North, and Tucson. So we leveraged that in the field as well. But we were in areas on the border where, we weren't able to receive those, and we were using differential corrections out there, and we were still able to maintain decimeter accuracy with fast acquisition times too. So it was an interesting.
Using SBAS in areas where you couldn't get RTK, right? And in that environment with clear sky, SBAS can be pretty good, probably a couple of feet or even less than that.
I will say, and this is anecdotal, but we are going through and looking at it. We were still able to maintain submeter corrections or collections in the field, but we were averaging about 1.5 feet in cold starts. But we kind of augmented our workflow to collect a point, fill out the form, and then reshoot the point at the end of the collection so the unit could kind of cook off a little bit. And we were still getting, honestly, 6 to 8 inch accuracy out there in the field with SBAS.
Gotcha. So here's the next slide. It was just more details about what you're talking about, 115. And I've been down there in Arizona in the summertime collecting data, and it can be brutal down there. And you're right, it's all about getting stuff done fast, right?
Yeah, like I said, we were not prepared to go into the field. We really were depending on using our vehicles and air conditioning to keep devices, the iPads, cold. And we had an over reliability on that because in this one slide right here, I don't know, you can see the power line going down the right side, but way back there in the back is the truck. So as you're collecting the information, you're walking 300, 400, 500 yards. And I wanted people to understand the scale of the area we were collecting in internally, but also for people attending this presentation. It's 125 degrees, and that's probably 9 a.m. in the morning right now.
Yeah.
That device is going to overheat. It's going to overheat very fast. So we tried a lot of stuff. And originally when we went out there, we were looking at collection times. We were only getting about 50 shots a day at the initial part of it. My goal was 100 locations a day. So we made some erroneous assumptions about how quickly we were going to be able to make the collection. And again, we had to come back and reevaluate our forms and our devices and the application. Some of these guys were doing pole inspections and basically had 2 teams following each other. We quickly realized that we were not going to do that. What we did is we embedded links to Collector or Survey 123, depending on what the app was that the person was using in the field. And so they could make a damage assessment, or they could make a telecom update, even if they were working in the electric collector.
Gotcha. I'm going to interrupt and just say that we got another, boy, it's amazing. This time is passing so fast here, but I wanted to make sure we got this question in. And I think primarily for Jeff and maybe for Ishmael, what solutions are available for navigating out to specific points with high precision for use to replace stakes in the field? And actually, Zach may be able to comment on that too, but I'll start with Jeff.
Yeah, so in Collector, in Explorer, and in Field Maps, we added a compass tool. And the compass tool lets you navigate to either a GIS feature, a point you drop, or something you searched for using a bearing and distance. Important in that, though, is that we're leveraging the compass that's inside of your smartphone. So it's only as accurate on the bearing side of it based upon the compass. we've been looking at, how can we evolve that functionality? Applications like, TerraSync and others have always had that capability to navigate to a point. We've been thinking about a couple of these. One is providing, notifications, local notifications on a device that you could convert into, an audible or a haptic feedback, taking advantage of, smart devices like a watch or whatnot, so you can keep your head up as you're moving and navigate to a location. And then it kind of comes back to the discussion earlier with you and Zach about 3D content. Should we start to look at an AR-based solution, and how viable is that with an accurate GPS system today? And would you use that as a heads-up display on your device or not? Lots of great questions on that. We're not sure we want to jump into the AR side of things quite yet. Seems like a good eye candy, but I don't know how practical it is in the real world yet. But
the question for you, Ishmael, there's the audience member says, Ishmael mentioned about machine learning capabilities being introduced in Survey 123. Will this include voice-based data collection like some of the quick capture demos previously showed? And before you answer that, Ishmael, I'm going to play a video. This is from Zach. This is kind of a neat thing here.
Open quick capture. PEC damage inspection app. Urgent. High priority. Medium priority. Low next maintenance cycle. Go home.
So that's pretty slick. Zach, can you comment about 15 seconds about how you use that in the field?
Yeah, we really wanted to speed up our and flag bird dog areas that needed immediate inspections, and also be able to take a picture without having to jump out of the truck and do all that. So we basically leveraged the voice recognition capability and quick capture. And basically everybody in the company has that on their phone where they can go out there. Everybody becomes a bird dog at that point. So gotcha. Big game changing.
So Ishmael, the question from the audience was, will you be introducing this into Survey 123?
Not in the same way. And let me explain this. Kind of our goal with ArcGIS Quick Capture is to reduce the user interaction with the device as much as possible for capturing data. So you can capture data quickly, right? That's the holy grail of the app, really. In the case of Survey and other applications, really our goal is to enhance that interaction, right? We know the user is going to interact with the device and we want to make that interaction rich. So completely operating the application using your voice, I don't think is practical in the case of Survey 123. However, when, say, you want to enter descriptive text in a question, then yes, it makes sense for you to speak and then let the application transcribe what you are saying. And that's actually already supported in all the Esri applications by that matter. Mm-hmm. So again, to reinforce the idea, fully operating Survey with your voice is not in our agenda at the moment.
Okay. And a follow-up question.
If there are any requirements, Eric, I would love to learn about those.
Gotcha. So another question from the audience, as long as we're on the Survey 123 track here. Ishmael, how would you approach performing a point in polygon workflow from Survey 123? I haven't been able to find any documentation on how to do this besides combining collector and Survey 123 workflows, which hasn't seemed to have worked yet for me. Actually, this is a good question because also we can talk about running Survey 123 and collector at the same time. But I'll start with you.
So there are different approaches to that. I'll be happy to connect with this user and share a couple of articles. But in short, you can do point-in polygons from the application using custom JavaScript functions. You can also use webhooks to do the point-in polygon queries.
Gotcha. And Johnny, if I'm going to shift over to you. So that question with regards to running collector and survey 1, 2, 3 at the same time, can you comment on that?
Yes, we have had capabilities in our app EOS Tools Pro on iOS, Android, in order to support both apps running simultaneously. So basically, you can have quick collector or field map running, and at the same time, quick capture and survey 1, 2, 3. Or, yeah, you can have all three of them running if you want at the same time and having access to the same data from the receiver.
Gotcha. Okay. Back to Ishmael, it was from the audience. It was mentioned when the crews know they are collecting high accuracy data, they input better quality data. What best practices can you share about how you format or structure your forms to increase data accuracy?
There are multiple techniques, and we actually have some blogs that describe these. I think there is a lot to say about warnings in your form, right? Like you want to keep your form clean, yeah. But if the horizontal accuracy is not met, or if the GPS has disconnected, or if the GPS doesn't have the proper fixed type that you want, if the user is moving, all of these are warnings that you can issue to the user to prevent them from capturing data in the wrong conditions.
Another question from the audience. This is for Jeff. Is it possible to export the settings from collector, for example, the location profile, the provider, and so on, and import into another device?
Hey, Eric. Yeah, I've been rifling through some of those questions and answering them in a written way, so that just so you know that. Sure. And this is one of them, but I'll just mention it out loud in case someone hasn't read that. We are working, so part of field maps, and we didn't really talk about this, is that there's a web app that's accompanying it. And we're taking a lot of the complexities of deploying maps to the field away from you with that, so that it simplifies everything. One of those that we're going to do is start to bring settings in. So the intention with settings like the ones that are mentioned here is that they're attached to your user profile, and they can follow you where you go regardless of the device that you're using. And we do have plans to add that into the web map. So it'll be coming. It's not there today. Right now, it's kind of per device that you have to do that entry, and not very palatable for a multi-device scenario.
Okay.
Yeah.
So is it an MDM type of approach, like an admin sort of thing? And I think you and I have talked about this personally in the past, is that, you know, if someone's got 100 users out there, are you able to control or able to deploy location profiles specific for devices and an admin kind of role?
Well, you can think about what I've just talked about with the web app as you as the GIS administrator setting that up, right? And being able to deploy it as a part of, you know, the user that signs in to the application. The MDM side of it, we can approach it that way too. The challenge we find with MDMs is that quite often it's the GIS professional doesn't have much influence in the MDM management, right? So, and it's rare you get into that IT group and you don't want to pester them too much, right? So you do it maybe one time for an app configuration when it's deployed. And we've got a bunch of settings around that, some configuration keywords. So I don't know that that's such a great approach. You know, there's very few organizations that want to go that way, more of a user-centric, and something that is like this, you know, especially things like a location profile. You might have a field workforce that's pretty distributed, and they're going to use different n-trip connections. They're going to potentially have different location profiles. You want that to be kind of more focused on the user that's than it is like a map or an organization-wide deployment, right? Gotcha. Yeah.
Hey, boy, we could go on for another few hours here, but our hour's up already. It went fast. I really appreciate it, Jeff, Ishmael, Zach, and Jean-Yves, and we've got to sign off for for now, but I really appreciate it, folks.
I want to thank everybody really for that participating, and also Eric for moderating. So thank everybody. And we will be answering the questions that were not answered. We'll answer them.
We got a lot of
afterwards.
questions out there. We'll get back to you. Great. Thanks, Jessica.
Thank you.
Thanks,
Thank
everyone.
you all.
Thank you.